How'd quiz 1 go? Did you guys get it solved? Alright, if not, here are the solutions. Number 1 is going to be an isolated system. Remember how we talked about an isolated system would be a special type of the closed system where it didn't have any interactions with the surroundings. Basically, we're just going to kind of assume that the surroundings don't affect it in any way. Now, in number 2, we've got a control volume. That's going to be a system that allows mass transfer across its boundary. So that'll be part B. And let's see, 3, we need to explain why the value for gauge pressure is always less than the corresponding value for absolute pressure. The reason why it's always less, I didn't leave y'all very much room here, is because the absolute pressure is equal to the gauge pressure plus the atmospheric pressure. Alright, so that's why it's always going to be less, because absolute is gauge plus atmospheric. Alright, so just remember this equation. We'll be using that as we go through the course. Number 4, we've got a closed system that has 4 pounds of gas undergoing a process during which our pressure-volume relationship is given as this, and gives us our initial values for pressure, which is 15, specific volume was 1.25, and then we end up with these final values, so 53 and then 0.5. We want to find the volume at states 1 and 2. We also want to find the value of N, and then we want to draw this process out on our pressure-volume coordinates. So let's see how to work through this problem. First of all, we know that mass is 4 pounds. We know this relationship here. So pressure times volume to the power of N equals a constant. And we also know our initial and final conditions, which will be important. So let's write those out. Alright, so second pressure is 53, and then second specific volume is 0.5. Now we've got that. Okay. With these things, we will be able to get what we need. So let's go over part A first. This is how you find the volume. We want our units to be in cubic feet. If you think back to our equation for specific volume, that's going to be 1 over the density. And remember the equation for density. That's 1 over the mass per volume. Now look, now we have volume in here. That's what we want. So let's go ahead and reorganize that. So essentially, specific volume is going to be volume per mass. And then if we solve for volume, we'll get mass times specific volume. And you can tell that just by looking at the units. So you really didn't have to go through all that, but in case you wanted to see it, there you go. Now let's look at the initial volume. That's going to be the mass, which is 4. That's not changing because this is a closed system. And then we're going to multiply that by the 1.25, and that's cubic feet per pound. Notice the units of pound goes away. That leaves us with 5 cubic feet. This is our volume for state 1. Then you do the same thing for state 2. Mass is still 4 because that doesn't change. And now our specific volume is 0.5. Again, double check your units. That works out to cubic feet. And then multiply your numbers. You get 2 cubic feet. All right, so we are reducing the volume. We started out at 5. We end up at 2. Alright, so that's part A, that's done. Now we have to find the value of N. And the way we're going to do that is we will use this relationship right here. So let's set it up. Now we know the pressure and volume at state 1 and state 2. So using those values, we're going to plug those in. So at state 1, we've got a pressure of 15. We're going to multiply that by our volume, which we just found, which is 5, and then raised to the n power, and then over here we're going to have 53 psi times 2 cubic feet. That's raised up to the power. And now we're trying to find this N. So let's reorganize this, and you'll see that we don't have to worry about the units because they're all going to go away anyways. If we reorganize this, let's put the pressures on one side. We'll put the volumes on the right side. So we'll end up with 15 psi over 53 psi. That's going to equal 2 cubic feet over 5 cubic feet. And then this quantity is raised to the power of N. So now I just go through and do the units. Notice they all cancel out. This is going to leave you with 0.283 equals 0.4 to the power of N. And then with that, you can just use natural log to solve for N. So we'll have natural log of 0.283 equals N times the natural log of 0.4. So N then is going to end up being natural log of 0.283 over natural log of 0.4, which gives you 1.38. So there's your value of N. All right, so that's how you go about using that pressure-volume relationship to find N. And then the last thing is part C. So this one you just want to sketch the process on the PV diagram. So this will be volume, this will be pressure, and you already know your initial and final values. So for state 1, we're going to have a volume of 1.25. Pressure is going to be 15. So let's just put those values there. So that'll be state 1. And then state 2, volume drops, and then pressure goes up. So let's put 53 here, and then we'll put 0.5 here. So that'll be state 2. All right, and we're going to go like that. Okay. So there you go. That's what you should have gotten on your quiz. Hopefully y'all did well on it. I will see y'all next time.